This video will explain where the soil ultimate bearing capacities come from that are provided in the manual and then used within the bridge design course. So here I'm talking about this QU equal to 286 kilopascals or 6,000 pounds per square foot. So I'm just going to show you where this comes from. So where to look first is actually the first volume of the Bridge Builder Manual. In Volume 1, Section 4, Table 4.1, it shows the different types of soil, not rock, soil that is encountered, and just based on the Bridges to Prosperity and Engineers in Action experience, typically our sites are coarse-grained, gravelly, or sandy soils. You may run into a silty or clay soil, and these values in the manual won't apply, and so that'll have to be something that comes from the bridge program manager in country. If they can tell you what the soil parameters are, then we might need to substitute in a different value than the ultimate bearing capacity that's currently provided. So we assume there's gravelly and sandy soils, and then in order to get to the 286 kilopascals, we can reference the International Building Code. You can Google IBC 2018, it'll pull that up. You'll want to go to Chapter 18, Section 1806. And the first thing to note is that the presumptive load-bearing values that are provided in the below table we're going to look at will be used in allowable stress design load combinations, and that is what we've been using for our design. So when I scroll down to the table 1806.2, I know my soil type is going to be sandy gravel or gravel, and that's where we get to the vertical foundation pressure is 3,000 pounds per square foot. And you'll notice that 3,000 PSF. So this is the allowable, right? So we come in here, so allowable stress design, that means that the factor of safety has already been applied. If I divide 3,000 by 2, a factor of safety of 2, if you multiply it by 2, you get the ultimate 6,000 pounds per square foot that you've been provided. So another place to see this in the manual is that when you get to the bearing pressure check equations 4.24, it says that the designs in the manual assume an ultimate bearing capacity of 286 kilopascals and 6,000 pounds per square foot. And so that's where it comes from. We assume a factor of safety of 2. And so as Jay has gone over, we take the ultimate soil bearing capacity to get the allowable. So the allowable bearing pressure needs to be greater than the maximum bearing pressure that comes from your abutment. And so we take the ultimate, the 286 kilopascals divided by 2, and you get the 143, which is your allowable bearing pressure. And then you're checking that that value is larger than the maximum bearing pressure you actually get from your abutment. And that's why we're giving it to you here in the manual as ultimate, but you can see it as in the already allowable form within the International Building Code.